Now let's say we want to determine the coefficient of x to the power of 16 in this expansion of 1 plus x squared to the power of 5 times 3 minus x to the power of 10. So there are a few ways how we can do this. One is we can expand each of this, okay, using the binomial expansion, and then we multiply all the terms, okay, until you get the terms in x to the power of 16. That's one way. Okay, the other way is to find the r plus 1th term of each expansion, and then we multiply it, and then we find the combination that gives us x to the power of 16. Okay, so as a start, let's say for this 1 plus x squared to the power of 5, if you expand this, the term in x squared, okay, you will get x to the power of 2, okay, to the power of 1, okay, which is x squared, and then there'll be x to the power of 2 to the power of 2, that's x to the power of 4, and you will get x to the power of 6, x to the power of 8, and x to the power of 10, okay, once you reach power of 5. And then for 3 minus x to the power of 10, if you were to expand this, the terms in x would range from x to the power of 1, okay, x to the power of 2, x to the power of 3, 4, 5, 6, 7, 8, 9, and 10. So in this case, if you multiply all the terms in x here, which would give you a combination of that gives you x to the power of 16. Okay, so in this case, let's say if you have x to the power of 6, okay, then that has to be multiplied to x to the power of 10 to give us x to the power of 16. Okay, that's the first combination. And then the next one for x to the power of 8, that will be multiplied to the term in x to the power of 8, okay, to get x to the power of 16. And for x to the power of 10, that will be multiplied to x to the power of 6, okay, to get x to the power of 16. So in this case, if you were to follow the first way, which is to expand each of those terms in the bracket, and then you will need to multiply these terms together. Now the other way would be for us to determine the r plus 1th term of each expansion. Okay, so let's say for 1 plus x squared to the power of 5, okay, let's say the r plus 1th term, okay, is represented by 5 combination of r, okay, 5 combined r here. Okay, then we have 1, of course this is 1 to the power of 5 minus r, that's 1 anyway. Okay, and then you have x squared to the power of r. Okay, so that gives us the r plus 1th term for the first bracket. Okay, and then for, of course, this would simplify to 5r, okay, and then x to the power of 2r. Then for the next bracket, which is 3 minus x to the power of 10, so we'll say that the k plus 1th term, so I wouldn't want to use r again, okay, because the range of value for r here would be different from k. Okay, so the k plus 1th term here would be 10 ck, okay, combine k here, and then there is 3, the first term in the bracket, 3 to the power of 10 minus k, okay, then we multiply by negative x to the power of k, right? And here, I'll simplify it, so I'll take negative 1 out, so there's negative 1 power k, and then multiply by 10 ck here, and 3 to the power of 10 minus k, and there is x to the power of k. Now, the thing to note here is that the values that can be taken on by r and k here would be different. So for r, the power of this expansion is 5. So in this case, there will be all the way, there will be 6 terms. Okay, if you put r equals to 5 here, 5 plus 1 will be 6. So there are 6 terms in this expansion. So in this case, r can be a value from 0, 1, 2, 3, 4, and 5. Whereas for k, it will be a value that goes from 0, 1, 2, all the way up to 10. Okay, based on the power of 10 here. Now we will multiply both these terms together since this is these two brackets are multiplied. So we will multiply the r plus 1 term to the k plus 1 term. So when you multiply them together, okay, what we'll have here is we have 5r, okay, and x to the power of 2r, okay, and then we multiply them by negative 1 power k, 10 ck, okay, and then 3 to the power of 10 minus k, x power k. Okay, and then we simplify everything. So there is negative 1, I'll just put it in front here. And then we have 5 combined r, 10 combined k. And then for the term in x here, okay, we will have x to the power of 2r plus k. And then not forgetting we have 3 here. This is 3 to the power of 10 minus k. Alright, now for this 2r plus k here, we need it to be equals to 16. Okay, because we are looking for the coefficient of the terms in x power 16. So in order for 2r plus k to be equals to 16, what kind of combination would they be based on these values of r and k? Okay, so of course you can put in values like r is equals to 0 and then find out what is the value of k. Okay, so let's say for example I'll express k as 16 minus 2r. Okay, and if r is equals to 0, then k will be 16 minus 2 times 0, which is 16. That's not possible because k can only be up to 10. Okay, that's the maximum value for k. Okay, and if you continue to do that for r equals to 1, so that's k equals to 16 minus 2 times 1, that's 14. Again, that's not feasible. Okay, and then you can go all the way up to, say, r equals to 3. Then k is equals to 16 minus 2 times 3, so that's 10. So yes, that's possible. That's the highest value of k here. And then you will take it for r equals to 4. Okay, and that's k equals to 16 minus 2 times 4, so that's 8. That's possible as well. And r equals to 5, the last value here, k is equals to 16 minus 2 times 5, so that is 6. So we will need to use these three sets of values and substitute them into this term, okay, to find out what is the terms in x power 16. So when r is equals to 3 and k is equals to 10, so this term here will be negative 1 power 10, and then we have 5, 3, combine 3, 10, combine 10, that's 1, and then we have 3 to the power of 10 minus 10, and then x to the power of 2 times 3 plus 10, that's 16. Okay, so this will be equals to, so negative 1 power 10, that is of course equals to 1. Okay, that's something that you can verify. Okay, and then multiply by 5c3 times 10c10, that's 1. And then we of course multiply by 3 to the power of 10 minus 10, that's 0. So 3 to the power of 0, that's 1. Okay, so altogether we get 10. Okay, so we get 10x to the power of 16. Okay, and then the next part, when r is equals to 4, then k is equals to 8. So we have negative 1 power 8, and then we have 5c4, and then we have 10c8, and then 3 to the power of 10 minus 8. Okay, based on our expression here, then there's x to the power of 2 times 4 plus 8, so that's 16. So again, we'll just repeat the same process again, but I'll just change the values here to x negative 1 to the power of 8. Okay, there's 8 there, and then there's 5c4, and then there's 10c8, and then there's 3 to the power of 10 minus 8. Okay, so that gives us 2025. So that's 2025 x to the power of 16. Okay, and finally, the final one is when r is equals to 5, k is equals to 6, then we have negative 1 to the power of 6, and then 5, then here will be 5c5, okay, and then 10c6, and then 3 to the power of 10 minus 6, okay, and then there's x to the power of 2 times 5 plus 6, okay, and what do we get there? So again, I'll just change this to 6. This is 5c5, which is 1, and then there's 10c6, and 3 to the power of 10 minus 6. So that's 17,010. Okay, so that's 17,010 x to the power of 16. So finally, the coefficient, so we can now conclude the coefficient of x to the power of 16 in the expansion is, so we'll just take the coefficient there, 10 plus 2025 plus 17,010. Okay, and that will be 10 plus 2025 plus 17,010. Okay, so that will be 19,045. Okay, so that's 19,045, and we are done.